All right, so this hopefully is the last video of this playlist. Um, okay, let's well, we could just look for places where there's camera TXY. Why not? Let's just do that. So let's obviously I'm not explaining all of this super thoroughly because I'm just completely sick of explaining this. Okay. So I'm just gonna keep on going. Okay, so here's some keyboard bindings, right? So the arrow left, right, up, and down, that's going to move the tile camera. And then we have the WASD, right? It's still like arrow type motion, but it's used for changing which memory cell is in focus or hot swapping index. So right now I'm using the term memory cell is like a zero indexed value describing subsections of the master memory that are 512 by 512 subsections. And then a hot swapping index is those exact same cells, but it is one indexed. The reason for the one indexed hot swapping cell is if the hot swapping index is 0, it means that we're not hot swapping any memory at the moment. Hot swapping, basically, all the memory needs to exist on a certain subsector of the master memory, and at any time that subsector can be hot swapped out for the isolated memory segment. So for example, maybe we want to load a level into memory and someone is doing work, right? And before they load the level into memory, we want to show them what it will look like and ask them, are you okay with overriding, whatever was already in this memory slot, right? So give them a chance to preview it by hot swapping the memory out, right? So reroute the shader code from using the master memory to using whatever is currently loaded into the isolated memory, right? So so basically the isolated memory is like swap space. And so we can temporarily use the isolated memory swap space to show people, like, here's whatever you're loading into the game will look like, but it's going to override whatever slot you're currently on. Do you want to go ahead with this change, right? And that's kind of, I don't know, old schoolish, right? Because, oh my god, you should support undo to 10 different levels or something. No, I'm not going to do that. Though if you do want to support something like undo, the way you do that is a command pattern usually. Just, Google a command pattern, right? So you record a queue of all the commands that were issued, and each command object has its logical inverse operation stored within it, right? So if you want to go back in your history, you pop off the most recent command, and you look up what the inverse command of that is and apply it. And then you want to go back again. You pop off another the next most recent command, look at what the inverse of that command is, execute that, right? And you can have undo, redo to your heart's desire if you keep a chain of all the commands that were issued. But that is a lot of work. That's a lot of work, and I don't got time for that. Okay, so let's keep on looking for where this camera tile X is. And while we're here, why don't we just do a little checking around here. So if we highlight TX, okay, we got 2 TXs and we got 2 TYs. That looks about right. Yeah, I'm happy. I'm happy with that bug check. Okay, there we did. We did some bug checking. All right, so cam TX. Let's go look for where you could be. Okay, find next. Oh, God, we're at the bottom of the file because we've been searching backwards this whole time. Okay, so we haven't gone over this yet. So we are in one of the initializers, one of the more informal initializers that comes after the main initialization. So initialize globals 002. So it comes after. So first we initialize configuration, then we initialize just data. And after initializing data, we initialize functions, and then we initialize classes, and then we have a global initializer 1 and then a global initializer 2, right? So that we can just keep track of the initialization order of everything and have just very strict and rigid order. None of this dependency injection stuff. No, we're not gonna, no. And the reason why I don't want dependency injection is, well, I have written dependency injection before, and, oh, it's nice because you don't have to think about the order of your dependencies. Oh, but it's not really nice because really you should know how everything is interrelated in your code base, and what you're just doing is you just wrote a really complicated piece of software so that you could be ignorant of the inner workings of your software. It's like a double fuck you over kind of a thing, you know, like, just why? Okay, so anyways, we have viewport C, that's our canvas. Viewport 0 is destination. Viewport 1 is the off-screen data sampler. That's actually being used by the editor number 2. And then this one right here is being used by... this one's actually being used by editor 1. So, right, the numbers do not align to what editor. The viewport numbers don't align to the editor. The viewports numbers are just serializing the purpose of the viewport rather than giving it some type of fancy name. So I need to codify this later. Viewport C, canvas viewport. So when you're zooming in and out of that Mandelbrot fractal, so let's go over here, and let's go to editor number 1, and go to shader number, shader slot 2, right? So this right here, the viewport responsible for this zooming behavior, that is viewport 2, and its job is to peruse over a conceptual data set. So there is no actual pixels here that we're scrolling over. We're just scrolling over these conceptual frag chords that we can zoom in and out of. So viewport 2 is for mapping over conceptual data, and then viewport 1 here is for mapping over actual data that actually exists, right? So I wanted to keep those purposes kind of like explicitly different. So when we're in this editor, like these colors you're seeing actually are actual data stored in a texture, and so viewport 1's job is to browse subselections of actual data that kind of physically exists somewhere, right? This data right here that we're looking at exists as values stored in GPU VRAM, right? Whereas the other editor right here, I don't have any individual pixel values. I don't have like some Mandelbrot image in GPU memory anywhere, right? These are just like GL frag chords that are generated on the fly, and then I'm sampling subsections of the data set of the GL frag chords, right? So the data set is much more conceptual. It's not as tangible. It's weird to say one thing's physical and one thing's tangible when it's like all data, so what do you mean tangible? But that's kind of why I have these two different viewports, because I always want the purpose of a viewport to be very strict, right? Kind of that like Linux philosophy of like do one thing and do one thing well. Okay, so what time do we have? We got 9 minutes. Let's see, maybe we will get to the part we were looking for. Maybe we'll keep on getting distracted. So right here we are loading the editor 2 values to sensible defaults. So if we highlight this, we can see editor 2 right here. You'll see that hackish static function referenced here again, and that's because we need to make sure that the tile exponent and the tile span are always directly related to each other, and we could just set this and then make sure that directly after we set this using math.pow to and then to this tile exponent, but that could lead to trouble. So this is kind of hacky, but that's what you get for caching data. That's what you get for optimizing, you know. And that's why you should always try to not optimize. Try to save optimization for last, because optimization just makes code confusing. Okay, so let's keep on looking for where this CamTX is referenced in the code, because, oh, okay, there we are, we're back here, but we have not yet hit the shader code. Are we still going backwards? We are not going backwards this time. And, okay, here's where it's wired up in the defines of the shader code, so yeah, we're getting warmer, right? Because before we can use these values in the shader code, we need to hard code the data's location by using defines. So we're at the top of the shader code right now. So let's go find next. Oh, hey, look, this looks promising, CamTX, and since I just recently worked on this, I know I'm in the correct section. So we got this like E2 right here that stands for editor 2. It's just a nice way to, right, when we're like browsing through all the data, it's like, oh god, where is E2? Where's E2? Okay, there we go, right? So that's, guess you could say that's kind of hacky, but you know, I find it nice just to tag things at the edge when you can, because it makes it easy to just scroll through and be like, oh, where are you? Oh, nope, nope, no, 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 no. Oh, there you are, right? So anyways, and the other thing is, right, I think I've mentioned this before, by being very OCD with making sure that everything lines up nicely. I know where the code has been touched recently and needs work, and I know where code has already been like pristinely figured out and I'm not going to touch anymore, right? So I want to write the code, and then, you know, once I do this to it, make it all nice and pretty, I never want it to be touched again. Now, obviously, that might not be the case. Eventually, you might need to make some edits. But the idea is that once you start to tear into this and make edits, everything is going to get misaligned. And it's going to be very obvious where you were making a mess and changing things around. And so it kind of self-signals to where changes are. It's kind of like a construction site, right? If we start tearing this apart, it's under construction. It's going to be obvious it's under construction. The visual style that you're going to see of the chaos is going to indicate where the construction is currently happening. So anyways, I guess we'll, okay, it's been 13 minutes. I guess we can get into this shader code. So this is a direct transcription of the code from the previous playlist. Like, we finally got to it. This was the goal of this playlist, was to just take what we had written in Canvas and move it into WebGL. And it's been a long time because I kind of like wanted to code a nice framework and not just throw it all together. So there's just a lot of stuff that, you know, did not pertain to this, but we finally got like all of the groundwork so that we had a nice place to put this code, rather than just throwing in a shader and being done with it. And the reason, like I said, is because not only do I want to write this to show you, but I also am working on an engine, so this is part of that work. So if we go over to the other screen, let's go over here. So this is dashed borders.htm from the previous playlist, and we tried to keep all the same variable names for everything, just to make it very easy to see the connections. So this do mapping function right here is what the shader code is. Specifically, right, there's some setup and whatnot. So we got our source and destination values. And down there's a loop, right? So this loop is basically your GL frag chords. So dx and dy, destination x and destination y, basically means the screen coordinate x and the screen coordinate y. All right, and then we have this little check here to see if we are outside of the viewport or not. And if we're outside of that viewport, we're just going to draw like a little border. So let's go look at what we have now. So you see how there is gray around here? That's because we use that kind of logic, but that is not actually the code because we rewrote the same similar logic. So if we go over to shader number 2, you see how the border is different? That's because we have the same logic coded twice, but I used a blue border this time as I transcribed the code from dashborders.html. So let's look at, so now that you've seen a glance of that, we're not going to do a side-by-side comparison just because it's going to be too hard for me, so I'm not going to. But I guess let's read through it a bit. So we have our rectangle source and our rectangle destination. So the rectangle source will be the sampler that samples a subset of the pixel data on the GPU memory. And the rectangle destination represents a viewport that is on screen. Okay, and then VPC height is viewport C height, also known as viewport canvas. And this is used, as you can see in the comment, to flip the coordinates. Because the origin in OpenGL is like the bottom left, and it annoys the hell out of me, but that's the way it is. So I gotta like always remember to flip my coordinates in every single shader I write, and it's kind of annoying. Now I could like make some type of top level GL frag chord variable that already has the value pre-flipped, but then I have to remember to use it. In a perfect world, yes, in a perfect world, that's what I would be doing, but I'm not. Okay, so right here, this is, I renamed the variable a little bit to be more consistent with my groupings of 3, so you see this 3 clustering here, and this is CX and CY, and we're probably never going to implement this or ever change it. It's always going to be 1.0, and basically that means that one tile is encoded as 1 pixel. So it's a 1-to-1 ratio of pixels to tiles. I don't really see any need to encode it any differently, but you know, if you want to encode things differently, I kind of put that math in there anyways. And that could be a bad thing because you don't need it, so why do you code it in there? Well, how do I justify that? Yeah, well, I guess there's no justification. I just did it, okay? I did it because I had it in mind, and I'm like, might as well stub this in here with the correct math, because, well, it's on my mind. It's going to be really easy to get in here, and it's not going to be so easy to implement this, you know, months later when you've forgotten what all this code does. Okay, so we got viewport 0 width and viewport 0 height. So these are the destination viewports. And we have, right, destination width, destination height. And we have some math. So the destination x1, destination x0 plus 1. So the equivalent math for calculating these. Same thing with the source width and the source height for viewport 1, right? So viewport 1 is also known as the source. So source, if you see, oh god. So anywhere you see, anywhere where you see source, you can swap out VP1, right? Those are equivalent. And anywhere where you see VP0, you can swap out destination, because they are synonymous with each other. Really, I should not be having synonymous variables. I shouldn't be fractionating my namespaces like that. But it has happened. It is too late. That is the way it is. Okay, so a little footnote here. CAMTX is CAM units. And notice there's a little hashtag here. And the purpose of that hashtag is just for me to know that this is a footnote. This is, man, I write way too many comments in my code. Maybe I should not clutter stuff up so much. Let's put that at the bottom of the file, right? And then just a little note here about, you know, CAMTXTY does not represent a tile / pixel in the top left corner of the camera. So the camera the camera's position is measured in cameras. So that's kind of weird to say, what's the position of your camera? Well, it's 2 cameras to the right and 2 cameras down, right? That's kind of weird, but that is the way my camera works. Because the camera it's a tile-based camera that is designed to snap onto tiles, because it is a camera designed for tile editing rather than for perusing the world. So it is not, by design, it is not meant to easily scroll fluidly. It's not meant for that. Now, we could add some tweening logic in if we wanted to, but I don't have any right now, and I'm probably not going to add any because that would just be like a little frill that is not necessary. We'll see where this goes. Okay, so we got the tile exponent, the tile span, the camera tx, the camera ty, and you notice that right now we are in declare all variables. So we're just declaring stuff. We are not actually using it all. I found while I was transcribing that there were just so many variables to sort out. I'm like, okay, I just need to list out all the variables used in the code over here. I needed to list out all the different variables that are actually used in this code and the ones that actually need to be transcribed, and just front load them and do it in a very kind of C style where I list everything ahead of time, right? And then we can, put comments on what the variables do in this section as well. So we don't have to have it interlaced where we declare the variable and then work with the variable. We can actually have a lot of information about what the variables do in this section. Okay, so remember how I said the hot swapping index is directly related to the concept of a memory cell, which is a subsection of the master memory, a subsection that is currently 512 by 512 pixels in size. That could change, but it's just that the master memory and the isolated memory, those two need to go into each other. They need to fit into each other evenly, right? So I need to always be able to chop up the master memory into even subdivisions of isolated memory in size. You'll notice that there is a prefix here, which is kind of ugly, but the thing is we already have a uniform called dexHot for the hot swapping index, and this variable refers to a certain hot swapping rectangle position, but it does not signify that memory has been hot swapped. So I want to keep the connections in the code as obvious as possible. So rather than call it this variable like memory cell, I'm actually just calling it this because I want the it is identifying the same regions of memory as the hot swapping index, so I don't want to name it differently. I want everything to be I want all the connections to be very obvious. If that was a mistake, I don't know. We'll find out. But this variable is ugly as sin. It's ugly, but if we have it just named like this, it will collide with the uniform that has the same name, so we had to do that. Okay, so let's clear this and keep on going. Okay, source and destination variables. So we have the source x, so the source x and source y, the start and ends, right? Start is 0, end is 1. For our inclusive range variables, it's been a pattern that I've been using pretty consistently with how I do my conventions. Okay, nx and ny is related to, so let's highlight this. So nx and ny right here is number of sections on x and y, and that is related to the implementation here of having more than one pixel encoding a tile value. So right now, number of sections right now we're going to have a 1-to-1 ratio, so nx will be equal to this formula here. There's no distortion at all right now, and there probably never will be. So just a little artifact of kind of like stubbing in the necessary thoughts for how I would do this without doing it, if that makes sense. It's kind of like that analogy of, you might want a pool in your backyard, so you build the garage off to the side. It's not too much extra effort to like reposition things a little bit and stub things in, but it'll save you a lot of work later if you actually do want to add this. Maybe I'm making a fool of myself. Maybe I should just abide by the you aren't going to need it principle, but it's just something I had a thought of, so I just stubbed in some of that logic. Okay, so source as, and then, oh god, I started abbreviating because column limits. So what did off, I kept notes, so I can just go OFFOMNI. Off monitor. Yeah, so originally this said off-screen data, but I ran out of room, so I'm like, oh god, okay, let's find an abbreviation and just throw it in there. So the source as off-monitor data pixel coordinates, and that is what is in this section here. So we have SX and SY for source X and source Y. More horrible abbreviations to keep everything within our column limit. So this is location bitmap / data. So this is the local SX and local SY. So this means that the first value of SX will be 0, and the first value of SY will be 0. So this SX/SY is within the coordinates of wherever the source rectangle is positioned. The source rectangle being VP1 in this case. VP1 being viewport 1. How much time we got? 26 minutes. Okay, let's keep on scrolling. So we have destination X's. So we're basically filling out some of the things that we've already been over. Destination as integers. We got local destination, right? So we have the, well, that's inconsistent. So we got local SX here and local SY. So this LDX, LDY is kind of like the same thing as this thing here. Right? The relationship between, hold on. So the relationship between this SX and this SY, these relationships, this global to local here, is the same as, where are we? Is the same as here and here, these guys, right? So this is global and this is local, and I did not use consistent naming because, like, right, we got this LOC SX, and then this is just LDX. Oh, well, I tried to be consistent. So, right, you gotta pursue perfection, and then you'll always fall short, but, if you didn't pursue perfection, you would fall even shorter, so... Okay, so what else? So TP0 width, TP0 height. What is TP0? Oh, hey, look, we got a little note. Tile size, pixels, 0. Okay, so it is the size of a tile measured in pixels within the context of viewport 0, right? So that's a pretty terse variable, but that's what it means, right? And then you have the width axis and the height axis. So then some more variables. So tile internal coordinates. So this is what we're doing to figure out the shading for the tiles, right? So instead of having that flat shading, we got these like nice square gradients going around everything. Those variables are managed by right here, these guys right here. That's what's responsible for that. So you got the X and Y within the tile, and then these four down here. So this is the lower bounds, and then these are the upper bounds of where the tile coordinates can be. So the current position within the tile, the lower bounds, and the upper bounds. So these are the variables you would use if you wanted to map a sprite or hand-drawn like image onto the tile rather than rendering a gradient, right? So instead of rendering this gradient, we could actually put a hand-drawn graphic or a pixel artist drawn graphic. We could like paste it, lit it right there. split it right in there because we got all that coordinate value stuff. We got all the information we need to do that. But that's not what I'm doing. I'm going to stick with more procedural generated tiles, but you know, if you wanted to do that, like the groundwork is kind of laid down here for you. I'll be putting this on Pastebin. Okay, so comment square gradient, and we have the distance from the left edge, distance from the right edge, distance from the top, distance from the bottom, right. So TED, what does TED mean? Oh, tile edge distances. Nice. Okay, so what does MX mean? MX means Mav, Mav means Maverick. What the hell does Maverick mean? Well, Maverick means non-normalized. So non-normalized is a mouthful. I needed a nice concept, like a nice concise concept for the opposite of normalized. So I've been going with the word Maverick for a few years now, and I'm just going to stick with it, right? So NOR for normal, and then MAV for Maverick. And I'm just sticking with it. I don't know, deal with it. So MX is Maverick X, MY is Maverick Y, and so these are separate components, and this is, well, it says 1D and 1D, so obviously we somehow combine these components into 1D value and then 1D but normalized, and that makes sense because we are getting the what we're doing with these distance values is we want to calculate a square gradient. We need to find whatever edge is closest and pick that value to determine the intensity of the color. So that makes sense that we're going to filter down these 4 different values. We're first going to filter down these 4 values into X and Y components, and then we're going to take the X and Y components and we're going to filter them into this variable here, and then we're going to normalize that variable to get a value that we can work with easily in our shader code. Let's keep on scrolling down here. What time do we got? We got 31. Okay, I'll stop recording.